Hello, I am one student. I'm sorry I couldn't be here today with you, but what I want you to do is just follow along with this video, and we're going to prove some other triangle congruence conditions. So before we get started, you should have in front of you a piece of graphing paper, a protractor, and maybe a calculator, but it is not necessary. Okay, so let's go ahead and get started. We are on lesson 715. This is problem 7-52 in case you're following along. And I want you guys to remember, we're going to go down memory lane a little bit, that angle, 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 we decided that angle, angle, angle was not enough information to say two triangles were congruent. We always needed some sort of side. But what about side, side, side? Is side, side, side enough to say two triangles are congruent? Well, make your prediction like we've done in the past, yes or no. Take a moment, think about it. Now, once you've made your prediction, let's move on and let's go ahead and try to draw out two triangles, and let's see if side, side, side is enough to say two triangles are congruent. So let's go ahead and do this along with me. Like we've done in the past, I've given you some very specific instructions on your graphing paper. So follow along. Go ahead and put a dot right here in the corner. And then I want you to count over 4. 1, 2, 3, 4, and put another dot. Remember, 4 squares on your graphing paper is approximately 1 inch. All right, so now I'm going to go from the second dot, I'm going to go over 1 and up. 1, 2, 3, 4, 5. Now, I'm sorry, 5, 6. I want to go up 6. Now, if you are not sure, just kind of follow along with me. You can always pause this video if you need to. All right, I went up 6 there. Now, I can't do this, but with your when you have a protractor, I want you to connect these dots as nicely and as straightly as you can. Okay. Now, when you measure this bottom part right here, I remember I told you 4 blocks is 1 inch. IN is for inch. Now, if you were to measure this nice long side with your protractor, you should get 2 inches. And if you measure from this dot to this dot right here, you should get 1.5 inches. So make sure that you're able to do that now with your ruler on your protractor. Now, we're going to do that again over here. We're going to place a dot. We're going to go over 1, 2, 3, 4. And then we're going to go over 1 again and up 6. And I'm going to draw a second triangle. Remember, you're going to draw your edges very carefully. If you're using a protractor, your lines should be nice and straight, and your measurements actually should be pretty accurate. Now again, 4 squares is approximately 1 inch. Now if I use my protractor to measure this longest slanted side, it actually ends up being 2 inches. And then this shorter side right here is going to be 1.5 inches. And I apologize for my writing. Sometimes this thing works really well, and sometimes it gives me an issue. Okay. All right. Well, notice that when I measure these out, even if I did just the inch and the 1.5 inch, when I connect the two sides, the two dots together, I end up getting 2 inches. Same with the other side. So if two sides are exactly the same, that third side also has to be the same. That's how we get side, side, side. So side, side, side does work. It is a congruence condition. So if you predicted yes, good job. It does work. Well, now let's think about it. If side, side, side is a congruence condition, what about if I just have two sides? So I'm going to scroll down, but you guys shouldn't have to go down very far on your paper. So is side, side enough to say two triangles are congruent? Or do we need to add an angle? All right, so we're going to look at that next. So we're going to make our prediction. So decide if that's a yes or a no. And remember, there's no wrong answers at this point. So you got a 50-50 shot. I'm going to start again by drawing a 4-inch bottom. So I'm our 1-inch bottom by going over 4 squares. 1, 2, 3, 4. And then I'm going to do it over on this side. So I'm going to make another 4-inch bottom over here. So I've got this one piece to each of my 2 triangles. Now I'm going to make this side an inch, which is again is 4 squares. But I noticed that if I go up 4 over 1, this is also an inch. So I have an inch right here for the bottom. But I also have an inch right here and 1 inch right here. Now what I want you to do is take your protractors and measure this side, this nice long side. Are they the same or are they different? So again, you have 1 inch here. You have 1 inch here on this triangle. You have an inch on the bottom and an inch on the bottom. What are these 2 long sides? What are those going to be? Now I got that this triangle, the first triangle, has a 1.5 inch length, but on this triangle it's 1.25. So if you answered no, that's correct. Side side is not enough to say 2 triangles are congruent. It's obvious we need an angle. We need an angle to kind of lock it in. We need that angle to lock it in. So let's look at a different scenario. It's going to look very similar to the one on top. So let's go ahead and put side side is not a congruence condition. And I apologize. It does not like me writing S's on here. I don't know why. SS is not a congruence condition. But what about if I add an angle? And I'm going to add a very specific angle because we want something that's going to be very consistent. So I'm going to draw the same triangle again. I'm going to start with my dot. I'm going to go over 4, and I'm going to go up 4. So your triangle should look like this. Very similar to the one on top of it. Now I have this angle, which is a right angle. Hopefully you guys know it's 90 degrees. I apologize if I keep redrawing. I just want it to look nice. Okay, this is still 1 inch in length. This is still 1 inch in length. So now I'm going to draw that same bottom side right here. And I'm going to go up 4 right here. So I have an inch and an inch side. I'm going to make this nice right angle. And then I'm going to go over. Wow, these obviously look like 2 congruent triangles. But don't believe me, let's measure. Remember, this has to be 4 over. Did I go over too many times? 1, 2, 3. Nope, I didn't. 1, 2, 3, 4. Yeah, it's right there. Okay. This length right here, that long slanted length, should both be 1.5 inches. So if I have a side and a side, and I have this angle, that right angle, and again, I apologize, this is not working very well. And I'm going to do a big and sign. And right angle. Wow. Technology. I'm keeping trying here, guys. I'm not giving up. It's going to write 90 if it kills me. There we go. And the 90-degree angle, that is enough to say 2 triangles are congruent. We can say that. Okay? So your prediction for side should have been no. But for side with a 90-degree angle, that works. We're going to put a blue check mark. That works here. So what do we have? Right now we have side now. We have side 90-degree angle. We actually have another name for it. It's called hypotenuse leg. So you can just write it as HL. We have ASA, angle side angle. And we have angle angle, wow, eventually, side. That's a lot. So today we've looked at side, 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 and a hypotenuse leg, or that two sides and a 90-degree angle. But what about side, angle, side? Is that enough to say two triangles are congruent? So let's draw out some more triangles. We're going to do two different examples for side, angle, side. So this first example, we'll call this example 1. All right, let's draw our triangle. Try to draw it as close to what I have as you can, but it doesn't have to be exact on this one. Oh, my lines are not that straight. I wish I had a protractor. Now for this one, I'm going to tell you that this angle right here is 20 degrees. I'm going to tell you that this is 4 centimeters. So we're not going to be measuring this exactly now. And this is 5. And then over here, I'm going to tell you it's 20 degrees. And this is 4 centimeters. And this is 5. And what we noticed that is that if I was to line these up or use a rigid transformation and I was to swipe this over one on top of the other, both would be congruent. They both have a side, an angle, and a side. Now, if you notice too that that angle is between the two sides, consider that angle locking it in. It's locking that two sides into that angle. All right, let's look at a different scenario where we're locking in that angle. Here's our next example. Again, try to draw the triangles with me, and if I'm going too fast, make sure that you pause the video and then you can draw what I'm drawing and then restart the video. All right, now this one, I'm going to say that this is still 4 centimeters. Promise that's a 4. This is 5. And this one, instead of 20 degrees, that's much bigger. We're going to say it's like 100 degrees. And this triangle's 4, this triangle's 5, and this is 100 degrees. Now we can't use Pythagorean theorem to decide if these two triangles are congruent. We don't have a right angle. If we had a right angle, we could do that. But our angle that's locking us in here is 100. And because the angle is in between the two sides, we can say that triangle is locked in. If I draw the line that's longest, it's going to always be the same length. Therefore, side angle side is enough to say two triangles are congruent. So side angle side works. Now we can add that to our list up here. Oh my gosh, look at this. Okay, now that we have all of these, that's a lot of ways to show two triangles are congruent. But the big question is always, does ASS work? Why does ASS not show two triangles are congruent? So draw a triangle with me. This is the last two triangles you are going to be drawing today. So you're almost done. All right, so now I have this triangle right here. Notice that we do not have this angle right here locked in. The angle is over here. So it can actually move this side right here, this side that's longest. It actually can move this away. And because of that, because I can move, and this is unknown, this angle is unknown, I can't say these two triangles are congruent. I'll show you another example. Sorry, let me change my color here. Here is another angle. Oh, that's a right angle. Oh my gosh, I almost misproved my point. So again, if I know this side length is 5, this side length is 4, but I don't know this angle in between, it could be anything. Here it could be 100 degrees. And if it's 100 degrees, then this side, this longest side, is going to be longer. Therefore, these two triangles are not going to be congruent. Oops. Sorry, I didn't mean to do that. 1 second, kids. I'm doing this too late at night. This angle right here is going to be 60. All right. So, because I don't know, and I'm going to say this one more time so that I can be extra clear. Because I don't know this angle right here, this angle doesn't have to, it's not locked. It doesn't lock in these two sides. Therefore, because I only know this angle, I do not know this one, and I do not know this one, I cannot say these two triangles are congruent. It's very easy for it to be a whole different angle. So remember, if you see ASS, or you see any representation of ASS or SSA in your work, we cannot say those two triangles are congruent. All right, guys, I hope that was helpful. If you have any questions, please email me. Otherwise, I will see you on Friday.